Everyone, today we're going to be looking at frequency tables and tallies, as well as then how to convert that into a visual column graph. Right. Now, frequency tables we use to organize either numerical or categorical data, and we use a tally to begin with and then convert that into our number frequency. And the reason we do that is because tallies are just a lot easier to collect and then writing our number out afterwards rather than writing 1 and then crossing that out and writing 2, so on and so on. So what our tally marks look like is just your straight line down. And then when you're reaching that fifth one, you do a line across, right? For our green cars, we would just have 2 straight down marks. For orange, we would have our 5 and then 2 for 7. And the reason we do that mark across is, once again, it's easy to keep track of groups of 5 rather than just individual marks, okay? And then for our blues, we'd have 3 there. We could then use this to answer things like most popular car colours, which is what companies might do, right? They might look at the sales of their car colours and go, okay, well, for this model here, the red was the most popular, and so we're going to create more red ones, or they might do the same for the orange. Okay, so if we wanted to have a look at some of the statements here and answer them, we're just going to use that information that we've gathered. So true or false, did 5 people choose red as their favourite colour? Well, considering for our red we had the 5 tally marks and the frequency of 5, that is true. Now for the orange, did 9 people choose that as their favourite colour? No, we had 7 instead of 9, so that is false. Is blue the favourite colour of 3 people? Absolutely it is, because we had 3 people choose that, okay? And then did more people choose green than orange as their favourite colour? No, because our green, we only had the 2 people choosing that colour. Now, what we can do with this sort of organisation of data is, when we get a big list of something, is we can kind of go through and tally them off one by one. So we've got people who were surveyed on the number of pets that they have. And the number of pets they had varied between 1 to 6, right? And so for me personally, I have 2 pets, and I feel like that is quite common. But then you consider people who have things like chickens and fish, and it becomes a bit more haywire. Now, going through, we tally these off as we see them, right? So 1 mark for 1, so on, and so on. And now I just like to color code because I find it a bit easier to see. However, you can just use the 1 color, right? And then we have 2 tally marks for 2. We have 1 tally mark for 3. We're going to have 2 for 4. Oh, sorry, 3 for 4, and this is why I like to color code. 1 for 5, and then 1 for 6. Okay, so that means our frequencies for this are 6, 2, 1, 3, 1, 1. And the tally marks just help you from, they just prevent you from losing count. It makes it a bit easier to then get that frequency row later. Now, feel free to give this one a go by yourself. Pause the video here, however you might like to do that. This one here, students were interviewed on their favourite subject, and they were maths, science. I'm not biased here, I promise, being a maths science teacher, but maths, science, English, food tech, or HPE, right? And for something like this, it is easier to list just single letters as opposed to the whole word every time you do it, okay? But you might actually already have a table set up if you were to gather data this way. Then going through that, you're going to make your tally as per usual. So that would be 7 for the maths. And then for science, we've got 1, 2 there. For English, we have 1, 2 there. Food tech, we have 1, 2, 3, 4, 5, 6, 7. And then for HPE, we have 1, 2, 3, 4, 5. Okay, so we can then use this to sort of make some conclusions about that year level in terms of maybe which subjects might get more time, which subjects might need a review, etc., etc. So we can see our two subjects that were most popular were maths and food tech. They were actually tied for first place with 7 each. Was English more popular than HPE? No. Okay, because we had that 5 versus that 2. Which subject was least popular? In this case, it was both science and English with 2. Now, one question I want you to consider when we are looking at data is things like, can I generalize this, right? Could I use this to answer a question about all the students at Luther College? So just have a quick think about that and then unpause the video when you're ready. But we could not use this data to generalize about the entirety of Luther College, okay? And the reason for that is that all students interviewed were only in year 8, right? And so they're not very representative of Luther College as a whole. So all students interviewed only in year 8, which means that they're not going to be representative of, let's say, a year 12 student or a year 9 student. They're only representative of the year level. So we could use this data to potentially generalize about year 8 students at Luther College, but we couldn't do that with all students at the school. Now, from our frequency tables, we can then construct graphs, right? Graphs are a little bit prettier, but they also tell a story very visually instead. Now, we have 2 types of graphs here. We have a histogram, and this is used for continuous numerical data. Okay. Oh, sorry, I've got that the wrong way around. This is this one here is a bar chart, sorry. And we use them for discrete or categorical, right? Whereas on the right-hand side here, we have our histograms, which we use for continuous numerical, right? And the biggest difference between the two is this one has no gaps, whereas this one has gaps, right? And the reason for that being, if we think back to what continuous numerical data is that there's that constant flow on, right? And so in this category here, we have kids who got 0, 1, 2, 3, 4, and 5, right? And then they might have 6, 7, 8, 9, 10, so on, okay? And so it's including a range rather than just the one grade, okay? Because that would also be quite difficult to just get the kids who got 1, the kids who got 2, so on, okay? It gives us more of a story if we're grouping that data together. Now, if we wanted to construct one from our own frequency table, okay, we're going to figure out what our axes are going to be, whether we've got discrete or continuous data, and then working out things like our scale, okay? Now, what I really want to be asking in this line here is it discrete or continuous data that we're looking at, right? This one here gives us the number of siblings that students in a cohort have, okay? And because the number of siblings can only be 1 or 2, you can't have like 1.3 of a sibling, this is discrete data. And so we're going to have gaps in our graph, right? Now, on our x-axis, we always have the categories, right? So in this case, we have the number of siblings going on that x-axis. And then on that y-axis, we're going to have the frequency, okay, or the count, right? Now, because we're going to have gaps, I'm going to chuck 0 here, 1 here, 2 here, and 3 here. To get what our scale should be, we're going to take our highest number here, so 20, and we're going to divide that by the number of boxes we have available, which is 5, okay? So we've got the 5 boxes available, which means each box should be worth 4, just to make this spaced out really nicely. Now we're going to, it doesn't really matter what your colours are, if they're all the one colour, etc. But we're going to mark our frequencies. So the people with 0 siblings were 15. And so we're just going to draw our graph down from 15, right? Just making sure that we leave room 4 gaps, which I have. So we're just going to color in the entirety of this box, right? And then we're going to do the same for 20 and 13 and 2. And if you want to be really clear about how many there are, you can write the numbers above the graph, right? So on this one, I can write 15 just above it. Now for the number of students with one sibling, that is 20. So we're going to go all the way to the top. A lot of the time, these graphs are sort of generated by a software of some kind. And so they would be a lot more pristine than what ours is looking like, but that's okay. Then we've got 13 students with 2 siblings. So we're going to color that in as well, making sure to leave a gap. And then we're going to do the same for that third one with just the 2 siblings here. Okay. And so what we can see is that most of our students have just the 1 sibling as opposed to the 2 or none. Okay. Now feel free to pause the video here to have a go by yourself. But this one here, we're just looking at the number of words in a story instead. Now, once again, I shouldn't be asking numerical or categorical, but rather discrete or continuous, right? Now, in this case, because we're going from 0 to 99, 100 to 199, etc., this is actually continuous data that we're working with. And so that x-axis being the number of words, we're going to do like we did on that, well, what we saw on that first slide, where we have 0 here. And because it's 0 to 99, that second one's going to be 100, 200, 300, 400, and then 500, right? For our scale, our highest number is 12, and we have 6 boxes. So these will be worth 2 each, okay? Now, because it's continuous, all of our bars should touch, right? So 0 to 99. We're going to make sure we have no gaps between the columns on this graph. Then 100 to 99, we have 10. And sometimes it is just going to be time consuming coloring it in, right? But we have 10. And then from 200 to 299, we have all 12. Okay, so we're going to color in all 6 boxes. From 300 to 399, we have 8. So we would be coloring in 4 boxes. And then from 400 to 500, we have 3. So we'd be colouring in 1.5 boxes. And so we end up with our nifty little histogram right there.